Okay, Assalamualaikum and hi everyone. Okay, today I would like to discuss about equilibrium problem type 1. Okay, so for this type, the equilibrium quantities which refer to the concentration and partial pressure are given in the question. So you have to solve the value of Kc and Kp. Okay. For example, like this question, okay, at a certain temperature, the value of Kc is given in the question for the reaction. So 1 mole of nitrogen gas react with 3 mole of hydrogen gas produce 2 mole of ammonia gas. If the equilibrium concentration of N2 and NH3 are 0.015 molar and 2 molar respectively, what is the equilibrium concentration of H2? Okay. Alright, so for this one, refer to this one, actually, okay, so it's already given to you the concentration. Okay, this is the concentration of the reactant, nitrogen, and also, then this is the product concentration for NH3 at equilibrium. Right, and then we have to find out the concentration of H2 at equilibrium. So what should we do? Okay, first of all, right, you have to write the Kc expression. Okay, so remember concentration of the product divided by concentration of the reactant. So therefore, concentration of NH3 power of 2, since the coefficient here is 2, divided by concentration of NH2 times concentration of H2 power of 3, because we have the coefficient 3 here. Okay, so it's equal to the value of Kc, and then substitute all the values, right? So you will find out the concentration of hydrogen gas. So remember, you have to write the unit. Okay, so that is all for the lecture notes. Okay, so we take a look at the question number 2. Okay, at equilibrium, there are 2.5 mole, okay, SO2, 1.35 times 10 power of negative 5 mole O2, and 8.7 mole of SO3. Present in a 2-liter flask. Calculate the equilibrium constant Kc for the reaction at 700 degrees of Celsius. Okay. Alright, so now in the question here, it's not giving to you the concentration at equilibrium. Only giving to you the mole at equilibrium. So this refer to the mole of equilibrium and also the volume. So your first step, you have to calculate the concentration for each of the reactant and the product at equilibrium. Okay. So let's say we start with SO2, concentration SO2. Okay, we have 2.5 moles. Okay, divide by 12 liter. Okay, suppose you will get here 0.208. Okay, molar. So remember, you have to take 3 decimal places. Alright, next. And also the unit, don't forget to write. Okay, concentration of O2. Okay, 1.35 times 10 power of negative 5 moles over 12 liter. So this one you will get 1.125 times 10 power of negative 6 molar. Okay, and then concentration of SO3. Okay, so 8.7 moles over 12 liter. Okay, so for this one, suppose you get 0.725 molar. Okay, remember the unit for the concentration should be molar. Okay, right, next, write the Kc expression. Okay, so therefore, according to the equation here, so the value of Kc is equals to, okay, concentration SO3. Okay, since we have coefficient 2, so become power of 2 over concentration of SO2 squared times concentration of O2. Alright, next what she do, so we substitute all the values, 0.725 squared over KSO2, 0.208 squared, times O2, 1.125, 10 power of negative 6. Okay, so from here, when you calculate, suppose you get 1.08 times 10 power of 7. So remember, KC have no unit, remember? Alright, next, for this one, how many marks that you will get for this calculation? Alright, so since in the question not giving to you the concentration at equilibrium and you have to calculate, so each concentration at equilibrium, each calculation you will get 1 mark. And then you write the KC expression, another 1 more mark. Substitution, 1 mark. And final answer, no unit because this is KC, another 1 more mark. That is the maximum mark you can get from this calculation. Alright, next for tutorial number 3. Okay. So first, they mentioned to you the partial pressure of PCl3, O2 and POCl3 at equilibrium are this. Okay. Alright. So suppose the unit here is kPa. So tertinggal. Okay. Next, calculate the equilibrium constant Kp. Alright. So when I refer back the keyword here, important keyword already mentioned at equilibrium, which means all the partial pressure given here is at the equilibrium. So therefore, we can write the Kp expression. Remember, partial pressure of the product. Okay. Divide by partial pressure of the reactant. And the coefficient become power of. Okay. Alright, next, what should we do? Alright, since all the unit here is in kPa, same unit, so we just we can directly substitute. So if in the question given to you a different unit, then you have to convert so that all the unit become the same. Okay, POCl3 is 101 K power of 2 over partial pressure PCl3 5.05 squared. Partial pressure of oxygen 2.5. And when you calculate, suppose you get 160 with no unit. Okay, how many mark that you can get here from this calculation? First is the expression, Kp expression. Then substitute and final answer with no unit. Okay, maximum 3 marks. Alright, next question number 4. Okay, alright, so at 25 degree, H2O liquid reach equilibrium. The keyword here is reach equilibrium. Alright, next. Okay, Kp AKC. Calculate Kp, calculate Kc. The only data given here is vapor pressure of water. Okay, is 23.8 torr. Alright, first of all, you can write the Kp expression. Okay, alright, so for the Kc. Okay, as for this one, liquid is not considered in Kp and Kc. The information here, 23.8 torr, is referred to the vapor pressure of water, which means partial pressure of the H2O at equilibrium. So the value of Kp here is 23.8 torr. Okay, alright. In the question, not given to you the concentration at equilibrium for H2O gas. Okay, so therefore we cannot use this expression. So however, we can use this formula. Kp equals to Kc RT delta N. Okay, so please remember when you write, make sure RT is in round bracket. Okay, round bracket. and power of delta N. Okay, so now Kc is in unit of torr. We know that the R value that we are going to use is 0.08206 and the unit is L ATM per mole per Kelvin. So therefore, the unit of partial pressure should also in ATM. So then you have to convert torr into ATM. Okay, right. So when you convert, suppose you get here, okay, 0.0313. Okay, so remember, because this is not the final answer, so you have to take 3 to 4 decimal place. Alright, next, we can substitute into this formula. Okay, 0.0313. Kc is what we want to find out. The value of R here is 0.08206. The temperature, you have to convert into Kelvin. Since the unit of R here, we have per Kelvin. Right, so when you substitute, okay, this one, from 25 degree, then you get 298.15 K. And the delta N. So what is the value of the delta N? Okay, delta N, remember, sum of mole of product minus sum of mole of reactant. Okay, we take a look. So we have 1 mole at the product side. As for the reactant side is in liquid, we not consider. So meaning that 1 minus 0 is equals to 1. So power of 1. So when you calculate, suppose you get the Kc value here is equal to 1.28 times 10 power of negative 3. Alright, so how many mark that you are going to get here, right? So the first mark here is the Kp expression, 1 mark. And then the value of Kp. Okay, so remember for this one, no need to write the unit. Kp has no unit. Alright, so we erase. Okay, no unit. Suppose 23.8. Okay, next, the Kp and Kc formula ni, 1 mark. Okay, and then substitution and final answer Kc without unit, 1 mark. So as for the conversion here, usually there's no marks for the conversion. Okay, alright. So next, number 5. Okay, nitrogen dioxide dimerized according to the equation. Okay, 2 mole of NO2 gas produce 1 mole of N2O4 gas, giving to you the value of Kp at equilibrium. So this is the keyword here, at equilibrium. Right? So the partial pressure NO2 in the container is 0.15, and you have to calculate partial pressure N2O4 in the mixture. Right, so first of all, you have to write the Kp expression. So Kp equals to partial pressure of N2O4, okay, over partial pressure of NO2. Alright, since here is coefficient 2, power of 2. Right, next we substitute 7.13. Okay, partial pressure of N2O4. This is what we want to find out. And the partial pressure of NO2 is 1.5 squared. So therefore, you will get partial pressure of N2O4. Alright, so 0.16. Alright, so then forget to write the final unit that is referred to ATM. So how many mark that you get here? First is the Kp expression, the substitution, final answer with unit ATM. Okay, next question number 6. Okay, number 6. Okay. Right, so the following reaction achieve equilibrium. Keyword here achieve, meaning that already at equilibrium. Alright, so when the partial pressure of bromine gas is 0.6, 6 atm. Determine the Kp. Alright, so you have to write the Kp expression. Okay. Okay, Kp expression. Kp equals to, when refer to this equation, so this is heterogeneous equilibrium. So therefore, solid is not considered in Kp expression. So therefore, we'll get here partial pressure for Br 2 power of half. Alright, next you substitute 0.6 power of half. And finally, you will get here 0.775 without unit, okay? Right, so this is A. Okay, for B. So derive Kp equals to Kc RT delta N. So first of all, you have to write the Kc expression. So concentration Br2 squared. So this is equation 1. So Kp equals to partial pressure of Br2 power of half. This is equation number 2. Alright, next you have to use the ideal gas equation. Pv equals to nRT and then rearrange. Okay, mole over volume RT. So mole over volume here is referred to the concentration RT. Okay, so relate it with equation with partial pressure of Br2. So therefore PBr2 is referred to the mole Br2 over volume RT. Okay, mole over volume is referred to the concentration of Br2 RT. Okay, so this is power this is and then label. Please label equation number 3. Okay, we have 3 equation now. Alright, next what should we do? Alright, so substitute 3 into 2. Why into 2? Because we want to start with Kp. We start with Kp here. So 3 substitute into 2. So therefore Kp is equals to, round bracket, substitute equation 3. So Br2 RT power of half. Okay. Now, okay, so concentration we get here. Concentration Br2 power of half. Okay, you split RT power of half. Okay. Right, next. We substitute. Okay, this one we label equation number 4. Okay, 1 into 4. Okay, then you will get here Kp equals to Kc RT, okay, power of half. Okay, so this is, okay, so this is referring to the Kc. Okay, how many marks that you will get here for this question? Maybe start with the Kp expression, substitution, final answer. And then this one, 1 marks. Okay, derivation to become this, 1 mark. Okay, substitute. Okay, substitute. Okay, and then final answer. So that's all the maximum mark you can get from this question. And lastly is question number 7. Alright. The following equilibrium given to you 2 mole of SO2 gas react with oxygen gas produce 2 mole of SO3 gas and given to you the Kp value. Here you have to determine the Kc. Right, in the question not given to you any information about the concentration at equilibrium, only given to you the Kp value. So you have to use Kp equals to Kc RT delta N. So substitute the Kp value. Kc is what we want to find out. R is equal to 0.08206, and the temperature you have to convert from degree of Celsius to become Kelvin, 298.15 K. And delta N, remember delta N, sum of mole of product minus sum of mole of reactant. Okay, mole of product we have 2. Okay, 2 minus 2 plus 1 is equals to 3. So, delta N is equals to -1. So, we want to find out Kc. Therefore, Kc is equals to... Alright, so suppose you get here 7 times 10 power of 6. So, I think that's all for today. Okay, we see again in the next discussion. Thank you.